Hey everyone, Miss Mulville here. So today I am at a llama farm, which I expect a lot of you to be excited about, especially you, Avery. I know how much you love llamas. But what we're going to be talking about today is how to multiply a decimal by a whole number. So earlier this week and last week, you practiced estimating, which was developing your number sense. You did some modeling using the blocks to kind of see how decimals and multiplying them works. Today we're going to start finding exact answers. And something I want you to be aware of is whatever way that you've been multiplying all year long, you can stick with. So if you use the area model, partial product, lattice method, standard algorithm, any of those ways, stick with, okay? You can continue to use whatever way works best for you. Doesn't matter what kind of numbers that you use. So what we're gonna do to start today is we're gonna look at patterns. Because remember with math, if you can discover a pattern, it makes things so much easier when it's like that light bulb goes off in your head. So again, we're multiplying decimals by whole numbers today, and let's see if we notice any patterns. So what we're gonna do is we're gonna start with whole numbers. We have 2 times 35. Well, that's something that we've been doing since like 3rd grade. That's just simple, basic multiplication with 2 whole numbers. So if you know what 35 plus 35 is, well, then you know what 35 times 2 is. And 35 plus 35 is 70. Yeah, 70. So we're just going to write that there. And for now, I'm just going to put this decimal here just to remind you that a decimal is there after your whole number or after the ones place, even though we don't write it. But that might help us today. So our next one is 2 times 3.5, or we could say 3 and 5/10. Again, this is something that we worked on earlier this year. If you want to think of it as 3 and 5/10 plus 3 and 5/10, or 3.5 plus 3.5. Well, that's something that we could do when we're multiplying things by 2. Well, 5 plus 5 is 10. Got to bring it over. 3 plus 3 is 6, plus 1 more is 7. And of course, we've lined up our buttons, and don't forget about putting that decimal in our answer. So now the answer is equal to 7, and I'm just going to keep it as 7 and a 0 there. Anybody notice anything yet? All right, so let's look at our next one. So 2 times 35 hundredths. Again, these numbers look very, very similar. What we did when we were estimating was we said, okay, let's pretend the decimal's not there and let's multiply. So for now, pretend that this isn't here. It's just 2 times 35. So 2 times 35 we already know is 70. So we're going to put that there. But we're not doing 2 times 35, we're doing 3,500. So you'd have to think, where would that decimal make sense? Well, we know that 2 times 1 is 2. So there's no way this answer could be bigger than 2, because this number here is smaller than 1. And if something is smaller than 1, it's got to be smaller than this answer of 2. So would the decimal go here? Nope, because that'd be 70. Would it go here? Nope, that would be 7. That wouldn't make sense. Would it go here? Yeah, it definitely could go there as 7/10. That's smaller than 2. So the question is, do you notice anything? I don't know about you, but I do, okay? So when we have a decimal here, if you notice, there is one place after the decimal, okay? So there's one number after the decimal. And how many numbers are after the decimal in our answer? 1. Take a look at the one down here. If I have 2 numbers after the decimal, how many numbers are after the decimal here? 2. Now, let me throw this at you. Can't really see what I'm doing, so here we go. If I have 2 times, what if I had 0 and 35 thousandths? Could we pretend the decimal's not there? Yep, and do 2 times 35. Well, 2 times 35 is 70. And take a look. How many numbers are after the decimal? Well, there are 3. So how many numbers do you think are going to be after the decimal? Probably 3. So there's 1, 2, and what do you think we're going to have to add there? A 0. So that there are 3 numbers after. So if you have just figured out that pattern, that however many numbers are after the decimal, that's how many numbers you have to put after the decimal as well, which means that's how many times you've got to slide the decimal. So let me show you how this works. Basically, we're going to ignore the decimals and multiply like normal, and then count the number of decimals after that place, okay? And then that's where we're going to put that decimal. So let's try an example here. I'm going to pause this and erase it and set things up to make this a little bit faster. All right, so what I was saying before is that what you're basically gonna do is ignore the decimals, pretend they're not there and multiply, okay? Once you have ignored the decimals, you're gonna count how many numbers are after the decimal. So like here, how many numbers are after the decimal. And then what you're gonna do is you're gonna slide that decimal to the left that many spots, because when you slide decimals in the left direction, you're making the numbers smaller, which that has to make sense if we're multiplying by numbers that are really small, decimals, okay? So let's look at this first example here. I'm gonna start by doing it in standard algorithm, and then I'm gonna show you how it works for all other strategies too, okay? So pretend that decimal is not there. So basically just ignore it. Don't erase it for now, just pretend it's not there. So we would do 7 times 1, which is 7, and 7 times 2, which is 14, okay? Then we add that magic 0, as Kathleen likes to call it, to hold our place. And we do 0 times 1, which is 0, and 0 times 2, which is 0. Okay? So far, so good? Then you just add them up like normal. So we have 147. Now we know 147 would not make sense because our answer has to be less than 21 if this number here is less than 1. So this is where you have to count the number of numbers after the decimal. So how many numbers do we have after the decimal here? There's 1. So that means that we've got to slide this decimal that's currently sitting over here. It's an imaginary decimal that we don't write. We have to slide it over 1 spot to right there. So I'm going to, well, you know what? I'll keep the hump there for now. Okay. Do you see how we slid it from one place, slid it over 1? So now I'm going to make it super dark. There we go. So our answer would be 14 and 7/10. And then you can ask yourself, does that make sense? Well, if I have 21 times a number that's less than 1, well, I know it has to be less than 21. And is 14 and 7/10 less than 21? Yeah, that makes sense. Okay. So we can do this with any other strategy that we have. So I can do this with the area model. I can do the same thing. Pretend that that decimal is not there for now. 20 times 0 is 0. 1 times 0 is 0. 1 times 7 is 7. And 20 times 7 is 140. Again, I add all these up. So that gets me 147. And then I slide that decimal over how many spots? Well, same thing. Slide it over 1 spot. So take that decimal that's over here, slide it over 1 spot, and we still get the same answer. Same thing works with lattice method. Again, 2 times 0 is 0. 1 times 0 is 0. 1 times 7 is 7. And 2 times 7 is 14, which I just realized my boxes are crooked. Everybody hang tight. I did it backwards. Hang tight. Sorry, lattice method users. I drew my lines in the wrong direction, which hopefully you recognize that when I had it up here. See, even teachers make mistakes. And you know what? This is just how it is. This is how it works. I recognized it, and now I've changed it. I realized it wasn't making sense. So again, 0 times 1 is 0. 2 times 0 is 0. 1 times 7 is 7. And 2 times 7 is 14. You add up your columns. So 7 plus 7 is nothing. 4 plus 0 is 4. I just said 7 plus 7 is nothing. 7 plus 0 is 7. There we go. 4 plus 0 is 4, and 1 plus 0 is 1, and 0 plus 0 is 0. So we have 0, 1, 4, and 7. Again, how many numbers are after that decimal, which is here? There is 1, so slide it over. You guys can't even see it. Here we go. Slide it over, and do we still get the same answer? Yep. Now, same thing works with partial products. Here we go. So the way that I usually multiply, and I know a few of you do too, 2 times 0 is still 0, so I don't have to worry about that. 0 times 1 is also 0, don't have to worry about that. 7 times 20 is 140, and 7 times 1 is 7. Add those together, and I get 147. Again, how many numbers are after the decimal? There's still 1. Take that decimal, slide it over. There it is, 14 and 7/10. Every single strategy gets the same exact number. So this is my, my notice saying, do what works best for you. Okay, so let's try a few more examples together, and then you guys are going to practice a bunch on your own today. All right, so let's take a look at this first one here. We have 92 hundredths times 3. If you feel like you know what you're doing already and you want to try this on your own, pause the video right now, give it a go, and then check to see if you got it right. For everybody else that you still want some extra help, let's keep working. So what we're going to do is we're going to ignore the decimal and just multiply, pretend it's not there. So we're going to use standard algorithm this time. So we're going to do 3 times 2, which is 6. Then 3 times 9, which is 27. So remember, 7 goes down, 2 goes up. And then 3 times 0 is 3 plus 2. I said that right. 3 times 0. Nope. 3 times 0 is 0 plus 2 is 2. There we go. Okay, so we pretended the decimal's not there and we multiplied. So our next step is count the number of numbers after the decimal. So I'm going to use my marker here. How many numbers do we have after the decimal here? Well, there are 2. There are 2 numbers after the decimal. So that means that we have to slide the decimal that's over here to the left how many times? 2 times. So you're going to create 2 humps. You're going to go 1, 2. And now that's where our decimal is. It's right there. I'm making it big and bold. So our answer is 2 76 hundredths. And does that make sense? Yeah, because if we have 3 times something that's less than 1, it can't be bigger than 3. And is 2 76 hundredths bigger than 3? No, it's less than it. So that's good to go. That's where estimating can help you see if you're doing it right. All right, so we're going to do a couple more. I'm going to pause it. We'll try some more. All right, so let's take a look at this next one. So we have 170 times 3 thousandths. Take a look. That 3 is all the way in the thousandths place. Now, one thing, if you haven't noticed yet, is when you multiply decimals, they don't line up those buttons, okay? Because mathematicians know, they've discovered the pattern that it doesn't matter where that decimal is because you're not adding them up. They have understood that you just count the number of numbers after the decimal and slide it over. They know to ignore the decimal when they multiply. So yes, you'll never line up your buttons, as we've been saying, with adding and subtracting decimals. You won't do that with multiplying or dividing. Okay, so let's take a look here. We're going to multiply 170 really by 3 because we're pretending that decimal is not there. So we're going to do 3 times 0, which is 0. 3 times 7, which is 21. We're going to put the 1 down and the 2 up here. And then 3 times 1, which is 3, plus 2 more is 5. Okay? Now, if I were to multiply all of our next ones, so if I put that magic 0 down, I do 0 times 0, 0 times 7, 0 times 1, what am I going to get for all these? Yeah, I'm going to get out a whole lot of zeros. So if you want to do that, you want to add all these zeros down here, go for it. Or if you're a mathematician and think, I already know that all the rest of these will be 0, then you don't have to worry about it. Okay? So here we go. That was step 1. Ignore it. Second step, we've got to count how many numbers are after the decimal. So here they all are. How many numbers are after the decimal? Well, there's 3. So that means we've got to move our decimal over how many times? 3 times. So here it is right over here. We're going to slide 1, 2, 3. And that's where our new decimal is. So I'm going to make it nice and black and bold. So that means our answer, we like to put a 0 in the ones place, remember everyone, is 510 thousandths, or we could read this as 51 hundredths. You getting it? All right, we're going to try one more. Let's see if you can do this one on your own. All right, so here it is. You have 56 3/10 times 22. Okay, I want you to pause this video right now and try solving this problem using whatever strategy works best for you, and then you can check to see if you got it right. All right, give it a go. All right, for all my partial product people and lattice method people, you can check to see if your numbers are right. All my standard algorithm people, we're going to work on this together and check to see if you got your numbers right. So here we go. We do 3 times 2, which is 6. 2 times 6, which is 12. Put the 2 down, 1 up. 5 times 2 is 10, plus 1 more is 11. Now we're going to work in the tens place, which means we've got to have a 0 there to hold that spot. So 2 times 3, again, is 6. 2 times 6, again, is 12. So 2 goes down, 1 goes up again. 2 times 5 is 10, plus 1 more is 11. Almost running out of room there. And then add those up. I'm going to put my plus sign over here. I know that's not standard. Everybody hang tight with me, though, because there's no room over here. So 6 plus 0 is 6. 6 plus 2 is 8. 2 plus 1 is 3, and 1 plus 1 is 2, which is what you should have gotten with all these other ones. If you would have added all these other ones together, I put this in the wrong spot, sorry. Here we go, 6, 8, 3, 2. That works, okay? So once you add all, I forgot the 1. 1, everybody, 1. Here we go. Gosh, I'm making a lot of mistakes today. So 1 plus 0 is 1, and get you the 1 there. Okay, so here we go. we have to now count to see how many numbers are after the decimal. How many numbers are after this decimal? Just one. So how many times do we have to move that decimal over to the left? One spot. So currently it is over here. We're gonna slide it right there. So that means same thing down here with our lattice method. Move it over here. Same thing when you add all these up, you move it over here. So that means our final answer is 1,238 and 6/10. Is that what you got? Hopefully. If not, rewatch this video and see how this all works. But basically, your steps are ignore the decimal and multiply. So pretend it's not there. Then count to see how many numbers are after the decimal. And once you've counted, slide that decimal to the left that many times, just like how we did here. There's one number after the decimal, slide it to the left one time, and there's your answer. Okay? If you need more help or you're still stuck, let me know and I can see if I can help you in other ways too. Otherwise, good luck on those problems that are attached to this seesaw activity. I think there's 8 problems that you're going to be doing, or you can do it on piece of paper and pencil that your parents can print out for you. That's your decision. My suggestion though is whether you do it online or on paper, I would write it all down on a piece of paper or a whiteboard if you have it so that you've got lots of room. It's going to be really hard to draw like a lattice box on a screen and try to keep all your numbers lined up and write all your numbers really neatly. It's going to take you a really long time. So my suggestion to you is do all your work on a piece of paper and pencil or whiteboard and then put your answers online, or you can just send me a picture of all your answers and all your work that way. All right, have some fun today, everyone.